Hi everyone. I am really hoping that you're feeling really comfortable with highest common factor after that classwork and having marked it. I'm hoping that you learned from your mistakes. And I'm sure those last two questions, you were probably very confused with what's happening. And that's absolutely okay, because that was kind of an introduction to this lesson, which is on the highest common factor, but the more complicated questions. So the highest common bracket and what we call the switcheroo. Now, again, let me just say that this is a hugely important topic. And so if you ever are feeling a little bit lost or uncertain, or you can't figure out a question, please send me a message so that we can figure it out, because it's important that we don't fall off the bandwagon. So if you're feeling yourself confused at any stage, just send me a message. Okay, so what were those last two questions in the classwork meant to be trying to aim at? They're meant to be trying to get at this thing called the highest common bracket. So we're going to do two examples here. The first one teaches us about this highest common bracket. So the first question, example 1, says factorized, and there's two terms, and it's AB and 2A. Now this should be a really easy question. We look at those two terms, there's an A in common, and so we say to ourselves, what must we multiply A by to get AB back? We need a B. What must we multiply A by to get 2A back? And that's a 2. So there we go, that's our factorized. Now that was really easy, that's an introductory highest common factor question. So let's look at the next question. This question says x plus 1b plus 2x plus 1. So in the previous lesson, there was an example where we chose to multiply out a bracket. And it was simply because there was this one random bracket and we didn't really know what to do with it, so we multiplied it out. But in this question, have a look. There is a bracket with a b and then a bracket with the 2. Now I'm hoping you notice that these are identical brackets. X plus 1 is appearing twice. So the question is, does the highest common factor have to be an individual number or an individual letter? And the answer is no. A bracket, as long as it is an identical bracket, the entire bracket can be a highest common factor, as long as they are identical. So an identical bracket in each term can be a highest common factor. So I specifically chose this question because if you look at the previous question says A times B plus 2 times A. Now you notice this is exactly the same question. This is like A. Because check, it's AB plus 2A. It's just that instead of A being common, I've got an entire bracket that's common. So what did we do in A? In A, we saw, look, A is common, and we took it out. So here I'm going to say I don't care what's in the bracket. It is identical in both terms, and so I'm taking the entire bracket out as a highest common factor. It's almost exactly the same as the previous question where we took out an A. So I'm taking out x plus 1 is the highest common factor. So now I say to myself, well, what's left behind? What must I multiply x plus 1 by to get x plus 1 and then b? Clearly I'm missing a b. Now what must I multiply x plus 1 by to get x plus 1 but times 2? I'm clearly missing a 2. And you'll notice that's exactly the same as question A. It's just that instead of having a highest common factor of A, I've got a highest common factor of an entire bracket. Now this only works when the bracket is absolutely identical. And then I often think to myself, if I've taken this out and I've taken this out, I can clearly see what's left behind. It's b plus 2. Okay, let's try some more. Let's look at question C. Again, first thing that you always ask yourself when you factorize is there a highest common factor? So there's two terms here. There's a 2, an x, and a y minus 1, and a 3, and a p, and a y minus 1. So the moment I see a bracket, I say to myself, is there a highest common bracket? So I often call that an HCB, so a highest common bracket. It must be an identical bracket in each term. It can't have anything different. They can't have different signs. They can't have different letters. It must be identical. So I'm going to take out y minus 1 as my highest common factor, and it's actually a highest common bracket. So that means I've taken it out in both of these terms. So what am I left with? I'm left with 2x plus 3p. So it looks slightly different to the questions we were asking yesterday, because yesterday we just had a highest common factor out. We didn't have a whole bracket. but it's exactly the same concept. Okay, let's try the next one. I say to myself, oh look, there's two terms. Is there a highest common factor? Well, there's x plus y. Oh my word, there's an identical bracket. So I'm going to take out the bracket as a highest common factor. So I've taken it out. And so what am I left with? I'm left with 5 minus wt. So it's exactly the same idea. I multiply out, I can check if I'm working. So if I take x plus y times 5, I get 5 times x plus y. And if I say x plus y times negative wt, I get negative wt, x plus y. So it's exactly the same concept as our previous lesson. Okay, so how can it get a little bit more tricky? This is a question that people often struggle with because there's two terms. I see y minus 2 is common, so I take out y minus 2 as an entire highest common bracket, and now that's gone, so what's left behind? And lots of people just say a. Now, you can't have nothing left behind here. There has to be something left behind. And so this is the case, like we did yesterday, of the invisible negative 1 that can't be invisible when you're factorizing. You can't not put that 1 there. Because when you multiply back in, I want to say, oh great, I'm going to get y minus 2 times a. And then I still need to get minus y minus 2. So I have to have a 1 there. So just be really careful of where there's no other coefficient. There's an invisible coefficient of 1. So whenever you need that invisible coefficient, go and put it in, because in your factorizing, it can't be invisible anymore. Okay, so those were the basic introductions to the idea of highest common bracket. Can we see that a bracket can act as a highest common factor as long as it's identical? So this question takes that up a notch, because if I have a look, there are two terms. Here's x minus 1, there's x minus 1. X minus 1 is clearly common. So now I've taken that out of both terms. What's left behind? 2x minus x squared. Now what I haven't been bringing up in the previous questions, because it wasn't relevant, was, do you notice something about that bracket? Do you notice that 2x and minus x squared have something in common? So this is, I call this the left behind bracket. Once I've taken out my highest common bracket, I call this the left behind bracket. Now the only problem is we always have to check in that left behind bracket, is there still a highest common factor? Because I was only thinking about my highest common bracket. I wasn't thinking about other highest common factors. So always check your left behind bracket. Always check. So I shouldn't have written that. Let me try that again. Always check the left behind bracket for more highest common factors. Always check bracket for more highest common factors. So sometimes it's not only the bracket that was common. In this case, for example, yes, the x minus 1 was common. But if I look at 2x and minus x squared, x is also common. So now I'm doing a little mini highest common factor within the question. So I say to myself, what must x times by to get 2x? 2. What must x multiply to get minus x squared? So minus x. So first thing we do is we take out our highest common bracket, and then we check, does the left behind bracket still have its own highest common factors? Now, there's nothing wrong with the way that's written. We do generally like to put the single factors that aren't in a bracket at the front, but multiplication is commutative, which means it doesn't matter the order you write it. So in an exam, I would give you all the marks there. You don't have to swap it around. So let's look at our next example. Our next example says 3b a plus 4, so that's the end of the first term, and then 6b squared, oh gosh, and a plus 4. So immediately I see a highest common bracket. So my first step is always to take out my highest common bracket. So my highest common bracket gets taken out, and I now have a left behind bracket. So if that's been taken out, I'm left behind with 3b plus 6b squared. Now I need to check the left behind bracket, because there still could be more highest common factors in there. So in this case, my left behind bracket says 3b plus 6b squared. So immediately I'm like, hang on, there's definitely a b that's common, and there's actually a 3. So if I have a look, this is going to be a plus 4. And actually, let me take away that bracket because I haven't taken out my highest common factor. My highest common factor is a 3 and a b. So what must I multiply 3b to get 3b back? Well, 1. What must I multiply 3b back to get 3b by to get 6b squared back? So that's plus 2 and another b. So let's just check. That would be 3b squared, 3b plus 6b squared, which would be that. So if we want to write that neatly, we'll write 3b and then a plus 4, 1 plus 2b. Now you don't have to change the order. So just to summarize, what we need to have learned from example number 1 was the idea that a bracket, as long as it is identical, can act as a highest common factor. So we take it out first and we form a left behind bracket. The only thing we must remember to do is check the left behind bracket for more highest common factors. Right, so that's example 1, which is meant to teach us about highest common bracket. Example 2 is meant to teach us about something called the switcheroo. So let's have a look. In our first question, we have 2 terms, and I see b plus 1, and then I see 1 plus b. Now, a highest common bracket is only a highest common bracket if the brackets are identical. So a highest common bracket needs to have identical brackets. So my first question is, these brackets look similar, but are they identical? Now they're not identical because the one is b plus 1 and the other one is 1 plus b. My question here is b plus 1 equal to 1 plus b? Are these the same thing? Because if the answer is yes, then this is a highest common bracket and I don't have to worry. If the answer is no, then it's not a highest common bracket. Now the answer here, I'm hoping you realize, is yes, because addition is commutative. Now that word you'll note from class. Commutative means the order doesn't matter. When you add numbers together, it doesn't matter which order you write the numbers in. You will still get the same answer. So if I make this explicit, you can swap that 1 plus b around to b plus 1 and nothing changes because it is the same thing. So now I would say that b plus 1 is my common bracket, and I'm left with a plus 2. So that actually is just a very simple highest common bracket. It just looked a little bit more complicated. So let's look at b and ask ourselves, is this going to be the same idea? So in b, there are 2 terms, and this is b minus 1, but this is 1 minus b. So my question is b minus 1 the same thing as 1 minus b? Because if it is, I can treat this as a highest common bracket. Now the answer here is no, because subtraction is not commutative. So you can't just swap things around in subtraction and get the same answer. So for example, if you have 3 minus 1, that's not the same as 1 minus 3. You can't just swap it around. So the question is then, can we make b minus 1 somehow equal to some version of 1 minus b? Can we make them equal to the same bracket in some way? And here the answer is yes. This is called the switcheroo. So the answer is yes, and we call this the switcheroo for short. Now what the switcheroo says is, if you have 1 minus b as a bracket, and you want to make it eventually look like b minus 1, how do I go and do that? How do I swap it around? Because I'm not allowed to just swap it and leave everything the same like I could in example A, because this isn't addition. So here's the thing. can we factorize out a negative 1? So what we're going to do here is we're going to factorize out a negative 1. Because negative 1 times what will get me 1 back? Well, negative 1 times negative 1. Negative 1 times what will give me negative b back? Well, plus b. So just have a look at that. What I've done there is I've factorized out a negative. So multiply it back in your head to see if this is actually still equal. So negative 1 times negative 1 is 1. Negative 1 times b is negative b. So that is actually right. Now, am I allowed to write the positive b first and then the minus 1? And that answer is yes, because you're not swapping the order. I'm moving the terms around with their sign, and that's always allowed. And so guess what? I can rewrite it as b minus 1 as long as I change the sign outside the bracket. So as long as I make there a negative sign outside the bracket, I can swap my b and my minus 1 around. So if I change the sign outside the bracket, so 1 minus b is the same thing as minus b minus 1. So I can swap these around if I change this sign. So every single time we don't go through this whole thing of factorizing out a negative 1 and swapping it around, we kind of go, oh, that's interesting. You're factorizing out a minus 1 and then it does match. And basically then we learn off by heart that the switcheroo says, and I'll write this down in a second, the switcheroo says if you have a minus sign, these brackets are not identical. What you can do to make them identical is you can swap these terms around with pleasure, as long as you change the sign outside the bracket. So if that's a plus sign, it's now going to become a minus sign. So what this means is that if I have a times b minus 1, I can swap these around to b minus 1 as well, as long as I change the sign outside the bracket. So in the next question, I'm going to write a note on what the switcheroo means, but that's what it means in words. Now what it's done for me is it's created a highest common bracket, because now my b minus 1 is common. So now I can say I have b minus 1 as the highest common factor, and I'm left with a minus 2, not a plus 2, because I had to change the sign outside the bracket. So in the next example, let's write a note on this. So if I look at my question, I see d minus 4, and I see 4 minus d. Now this is not a plus sign. So this is not identical brackets. And so what the switcheroo says is the switcheroo says if there is a minus sign in the bracket. So the switcheroo says if there is a minus sign in the bracket, only works with the minus, because if there was a plus you could just swap it around for free. So if there is a minus sign in the bracket, then you are not allowed to just swap the terms around, but you are allowed to do it if you change the sign outside the bracket. So then you are allowed to swap the terms around if you change the sign outside the bracket. So that's what the switcheroo says. So let me show you what I mean in this particular question. So in this particular question, you see d minus 4 and you see 4 minus d. That is not identical. It's not a plus sign, so you can't just swap it around for fun. So what that is saying here is 4 minus d is your bracket, and there's actually a minus 3 attached. So what they're saying is you are allowed to just swap these round and get d minus 4 as long as you change the sign outside the bracket. So if I write myself a note here, this swaps around as long as I change the sign. Because effectively what we're actually doing is factorizing out a -1. And if I factorize out a -1, this negative gets multiplied by the -1 and it changes to a positive. That's actually what we're doing. So if I look at this, my first line needs to be leave one of the brackets alone. You never want to change both brackets because then they both change to the opposite. So I'm going to change this to d minus 4. Notice it doesn't become a plus in the bracket. You're literally just swapping the terms around as long as I change the sign outside the bracket. Now my d minus 4 is common and I'm left with a c plus 3, no longer a c minus 3. Okay, let's try another one. There are two terms here. This is a minus 1, that's 1 minus a. It's not a plus sign, so I can't just swap it around, which means I need to pick one to leave. So I'm going to leave the a minus 1, and I'm going to swap the 1 minus a to be a minus 1, as long as I swap the sign outside the bracket. Now I have a highest common factor of a minus 1, and I'm left with x squared plus 4. Now I've been so focused on doing the switcheroo, I've been forgetting to check, does my left behind have any other highest common factors? And so far, none of these have had any highest common factors, and so I've been lazy at checking. Now just check x squared plus 4, no highest common factors, and so that's my answer. Okay, let's try two more. Next one, two terms, w plus 1, 1 plus w. Is there a minus sign? Oh no, there isn't. There's a plus sign. Now if there's a plus sign, you are allowed to swap around that term to be w plus 1 and nothing changes. This is not the switcheroo because it's a plus sign. And in a plus sign, it doesn't matter if you swap around the two terms because it's commutative. So I'm going to take out w plus 1 as the highest common factor, and I'm left with minus 3 plus x as my left behinds. Let me check my left behinds. Is there a highest common factor in my left behinds? And the answer is no, there isn't. Okay, so don't now see every bracket as a switcheroo. If there's a plus sign, it can swap around without any problems. Okay, last one. Two terms, x minus 1, 1 minus x, classic switcheroo, because you have a minus sign and it's the wrong way around. So I'm going to leave the first bracket. I'm going to swap the second bracket to also be x minus 1 as long as I change the sign of the coefficient. Now my x minus 1 is a common factor and my left behinds are p squared minus p. Question is, do my left behinds have a highest common factor that I didn't notice before? And the answer here is yes. So x minus 1 is my highest common bracket. P is common in that second bracket, and I'm left with p minus 1. How am I left with p minus 1? Because what times p will give p squared? Well, p, and p times what will give minus p, and that must be minus 1. So if I want to write this neatly, I'll put the p first, and then my two brackets. But ultimately it doesn't matter. Okay, so what have we learned in this lesson? We've learned that a bracket can be a highest common factor if it's identical. If it's not identical, we ask ourselves, is it a plus sign, like in example E, in which case you just swap it around, it doesn't matter, they actually are identical. Or is it a switcheroo? A switcheroo means that, like in F, there's a minus sign and the terms are the wrong way around. So they're not automatically equal, and you want to swap them around to make them equal. And so in order to do that, you need to change the sign outside the bracket, and then you can swap it around. And then you can continue as normal. And that's the switcheroo. Now, there's not so much classwork / homework for today. You can probably finish it in the lesson because it's exercise 18.14 on page 251, and I think there's only 8 or so questions. So I'll post the memo, and especially in this, as it starts to get a little bit more complex, make sure that you ask questions if you don't understand the memo once you've done it. Well done.